Hope you all had a nice weekend. Plan for today is we'll just keep on working with R. So maybe useful to have R opened up, certainly for what we're going to do next. So we were working with this kind of worksheet that was dealing with working with vectors and data frames last time on Thursday. So we'll pick up with that. I was working from this PDF, which is posted up on Canvas, but there's our markdown version of this as well that you can edit and interact with. And we'll be working with a second R markdown file called data exploration that we'll be working on for most of this class. So if you're kind of having trouble finding that stuff, it is all posted in Canvas. Let me see what's open. This is, yes. Okay, yeah, so you're looking at my Canvas, I think. And here's our class. And I added a module over the weekend for week 2. So the documents that we'll be finishing up today is this PDF version, Foundations of R, and then we'll begin this data exploration. And there's a PDF version, which is just what I got when I knit this version. So there's really nothing different between the R markdown and the PDF version other than one was rendered and one wasn't. So might be useful to have this. And I think I might be able to drag that into the chat if you don't. Yeah, personally.
When I attempted to look at the PDF knit version, when I tried to print it out, it showed just one page that was extremely long. I didn't know if there were different settings.
Yeah, so the way I knit that is I knit it to PDF. To HTML, and then I converted that HTML to a PDF. And so when it did that, it did not paginate it. Yeah.
Okay, thank you.
Yeah, you can knit it straight to HTML if you like and work with it from there. I just wanted to post a PDF version up here, but technically that was an HTML that was converted to PDF. And so I'll just say there's kind of this balance when you're rendering these R markdown files. PDFs tend to look nicer, I guess, in the end than HTML files might. So it's nice to render it right to PDF. But if you've entered some LaTeX code in your markdown file and you don't have LaTeX and stored on your computer, then it will crash. And so that's why I knit to HTML, because it doesn't require a local installation of LaTeX. Okay, are there any other questions before we get started? I'm doing my best. We got a large class, so trying to keep on top of what I'm trying to say, comments that are coming in from all of you. And so if I happen to miss someone's hand up, or if there's something in the chat that I missed, you know, we're informal here. You're welcome to just unmute yourself and let me know. Any other questions before we get started today? Let me see if I can plop in some of these documents into the chat. So I want my R markdown. Okay, so I did just move the R markdown file that we'll be working with second in there. So if you don't have that, you can open up that presumably from the link. And this is what this PDF is what we were working on last time. So they're both in the chat. Okay, so if there aren't any other questions, then I will pick up with that second document that I just loaded. And maybe there's one more thing that I should chat, which is the R markdown version of this PDF that you're looking at. Let's see, where did I put that? Let's see. I think this should essentially be it. Okay. So I've got the PDF version of this, and I think last time we kind of stopped at when we were working with kind of some of the distribution functions in R and working with some of those examples, and we worked with vectors. So we're pretty much at this point in the document, which is working with data frames. And so remember that like a data frame is an array, a two-dimensional array, where now we're allowed to have heterogeneous stuff. So in other words, we don't need to require everything to be integers or everything to be decimals or strings or whatever. We can have some variables that are of one type and some variables that are of another. So for most of the semester, that's how our data is going to be structured and organized. It's going to be in data frames. So being able to create data frames, manipulate them, slice them, extract information from them, that's going to be really useful stuff. So when we're working with data in R or in general, usually we assume that the data is what we would call tidy. So this means organized so that each observation is in its own row and each variable is down each column. So you should think about each row in your table as one observation, one individual from your sample, and each column is measuring a different characteristic of that individual. And so what we're looking at down here is, this is just how we could create three different vectors. And so notice that this first vector D, let's kind of practice, what data type would like 1, 2, 3, 4 be?
Numerical.
It's numeric, that's right. And there are two different types of numerics. There were like the decimals and there were integers. And so what are these going to be by default read as?
Decimal.
I'm still here, sorry. Sorry, I think someone said it, but I might have missed it.
As decimals.
That's right. Mm-hmm. So by default, they're going to read them as decimals. And if you want them to be integers for some reason, just recall that you would want to put like an L after it, and that's going to save it as an integer. Yeah, so we've got vector D is a bunch of decimals. Vector E is a bunch of characters. And vector F is a bunch of logicals, and we'll talk about that in a second. So these are different than characters. Notice there's no double quotes around true and false. So true and false are like binary things like 0 and 1. And then we can take these three vectors that are of three different types, and we can combine them using the DataFrame function. So it's data.frame, and then you would enter each of the vectors that you want to be each of the columns. So in this case, D would be your first column, E is the second, F would be the third. And so what I've done over here is just kind of wrote to the screen what that data set would look like. If you were to view this in R, if you've got R open, keep in mind there's kind of like a first column that's really not part of the data frame. It's really just there for like referencing different rows. So it actually doesn't have an ID. It just might have, it's just identifying the row of the data that corresponds to. But this data set actually would just have three columns, right? D, E, and F. And oftentimes, yeah, you want to use more descriptive names for the header. So this D, E, and F we would call the headers for each of these columns, and we can pass through new names using the names function. So this will attach each of these names in order, right, for each of the columns. And as with many things, there's lots of different ways you could go about doing this in R. Some may be slightly more efficient than others, but at the end of the day, whatever you're feeling most comfortable with these days is probably going to be fine. I don't think we're running anything that's going to be too computationally affected by some of these differences. But you could, for example, have renamed these things in the same step when you imported them. And just know that here, first you would put the name, and then you would put the like the name you want to call it, and then you would put the vector that you're renaming ID. So this is going to take vector D and rename it as ID, which is the same exact thing that we've got up here. Any questions? So this data frame is like just a huge big chunk of, it's like an array, a heterogeneous array. But now that we have some headers on it, the way that we can extract information from it, we can either use row and column indices like we were doing with general arrays. Now we can use the fact that these columns all have names and use those as identifiers as well, which is nice. If you have like a really large data set with like 200 variables in it, you don't want to necessarily count out what column the variable you're interested is in. If it has a name, then you can use that as an identifier. Okay. Yeah, so probably like one of the most useful things to do is just kind of slice out an entire variable off of that data set, that data frame. And so that you can do with this $sign. So the df is our data frame name. So this is the data name. And this is what we called that column color. I think that was the second column in that data set. And just know that when you do this, if I were to do x df and then color, it now is going to save this information as a vector x. Okay, it's no longer going to have this data frame structure. We're not going to have the header there anymore. It's just going to contain whatever it was, red, white, and blue. Any questions so far? So let's think about these questions, and let me copy and paste this over. Okay, so let's just say we've got this data set over here, and I will just get rid of these identifiers since they're not part of the data frame. And so this is what we're calling df, is this whole data frame. So I'd like you to just think about each of these 4 different commands that are extracting some information from this data frame. So any ideas what the first command here would do?
So I think it just gives you the first row. So just 1 red and then true.
That's right. So, right, when we put these kind of square brackets, we first input, just like with matrices, right? We would first input the row index and then we input the column index. So we've got a row index of 1. So that would be all of this stuff over here. And we have a comma, and we don't have anything identifying any restrictions on the column. So that's going to pull off every column. So it's row 1, every column. So that would be 1 red T, and it's going to save that to a vector. Yeah. suppose you, yeah, I guess you could think about it as like a data frame with one row. What about B?
It just take the first two observations.
Yeah, so now we're gonna pull off those two observations. That's right, and every single column. What about C?
Just the second observation.
So C is the difference between A and C is like when we were pulling off the rows, right? The rows come first and then the columns come first. So notice here that 2 is specifying the second index, right? Which would be the column index. So we're not going to pull off row 2 here, but this is going to pull off the second column of that data frame, right? Every single row, but the second column. So it's just going to pull off red, white, blue, and A. And this one over here, right, is going to pull off the first 2 rows and the first 2 columns. So I think this would give me a data frame that just has 1 red and 2 white.
For C, will it come out as a vector, or how is that going to be displayed? Will it?
Yeah, good question. Let me open up R, since all of this stuff should be in here someplace, and share that. It should preserve the structure to answer your question. Where's my R? Over here. And I will zoom this in a little bit. So over here, if you're curious what I'm looking at, this is just the R Markdown version of this. And we are someplace down here, I think. Yes, let me create this data frame that I haven't done. Could we name it? Yeah, and so if you're curious what each of these things does in particular, what was I saying? I think I made something else up that's not quite here. Oh, here it is. So you're asking about this one, or which one was it? Sorry, Vasi, was it something like this?
Yeah, specifically C, but it doesn't really matter. I was just curious if.
Yeah, it should preserve that.
Yeah.
But it's always good to check. So we can just kind of plug this in. And so interesting. Yeah, so that just created it looks like a vector here, right? We don't have any headers there. Yeah. If you wanted to create that, you would have to then use like the data.frame, input this vector, and then give it headers if you wanted to. So it's just pulling off a vector in this case, but this is interesting because what if these things were different data types? Like this is unique because these were all the same data type character. If I were to do something like this, now that made it a data frame. Interesting. Yeah, good question.
So what does it do when you put the row and the column? Because wouldn't that keep it as a data frame?
So it's interesting that I don't know the intricacies of how this may be working. That's why it's good to play around with it. But it seems like when we pull off stuff that all has the same data type, it's by default making it a vector. It's reading this as this is one dimensional. And in fact, all of these things have the same data type. So that's going to be a vector. When you pull off a larger bit of information, and now we've got 2 different data types, it is reading that by default as a data frame, and it's keeping the headers there. The short story is just be careful. If you're not sure, just you can always print some of the output to the screen. Yeah. Okay. Any other questions? Good. So thanks for all of those like people with your cameras on. It's good. Our camera ratio is decaying a little bit. So luckily we just have hopefully one more Zoom class, and then we'll actually be in a room together. Okay, and so not to kind of hammer this in too much, because we'll be working with data frames a whole bunch, but right, instead of saying indicating the column numbers over here, we can indicate the names. And I'll just say these quotes should actually be the other way. This is just something particular about how LaTeX does things, but the should be regular quotes. But you would just put the name of the header in double quotes, and that would pull off color and past, for example. So this code down here is doing a whole bunch of things all at once, a couple that we've haven't quite talked about. So it's setting up a data frame similar to the command that we had back here. Just in this case, we first set up the vectors, and then we read the vectors in, and then we changed the names of the vectors, for example. So we did this in like multiple steps. What's going on in this code over here is that it's pretty much combining all of those steps into one big step. So this first command is creating a vector called numbers, which is the first 5 integers. So that's what numbers is looking like. That's just a vector of 1, 2, 3, 4, and 5. What do you think characters, letters is doing?
The first 5 letters.
That's right. So these things are pretty logical. And just keep in mind that it's going to do them as strings. Okay, and then you've got logicals that are defined below. So when you run this line, it's going to set up an entire data frame where the first column is called numbers, and that's 1, 2, 3, 4, 5. The second column is called characters, and that's A all the way down to E. And then the third one is called logicals, and those values are down here.
In the coding, do you need to have that space after the comma, or can you just have the comma to create new rows?
Yeah, you do not need that space there. In fact, pretty much all of the spaces in our code are not really read as anything. So whether or not you put spaces or even line breaks in your code doesn't really have an effect on the code itself, but more how easy it is to read. So sometimes people put those spaces in just to make the code a little bit easier to read, but it doesn't matter if you do or don't. Okay, and so I think what's going on down below is just similar way of slicing, just a different data frame. Okay, so any questions about data frames before we move to the next topic? With importing data, there's all sorts of different ways that you could go about doing this. There's like Readcsv is one type of command. The most general way of doing this is something that is using the read table function. This is the kind of in base R, and you basically just enter a file. So you have some file where your data is stored. That might be a CSV file, it could be an Excel file. I would say CSV files are comma separated. Those are probably the most universal ones to use. And so you can kind of just enter the file name, whether you want the headers to be pulled from that file or whether you want to just use generic headers. And then you indicate what is the character that's separating columns in my data set. So for a comma separated, that would be a comma. And that's going to import it right into R. using kind of this data, the same data frame structure. The thing that you're going to just need to be aware of is that, you know, R is going to do its best to think like what data type do you want each of these variables to do, and it might not do a good job. So if you've got dates, that's something that you might have to wrangle a little bit. So you may need to do some wrangling after you import it in terms of what data type you want to use. And we'll come across these issues together. So as we're working this semester, you know, we'll be using some of the data sets that are just like built into that Faraway package in R to kind of avoid these issues. And I think at other times, it's going to be useful for us to kind of not avoid these issues and kind of deal with these head on. But I will say that that's an entire class in itself called data wrangling and visualization. And that's a plug for Math 3376. If anybody's interested in taking that, you'll learn a whole bunch of stuff in R to deal with this exact page here, right? We could deal with a whole course on that. Okay, so I will kind of skip messing around with this file over here. We don't need to play around with that today. But what I do want to talk about, the last thing I want to talk about on this set of material is kind of extracting data based on logical statements. Like if the year is greater than 2000, I want to keep all of those. If the year is less than 2000, I don't care about it, that kind of stuff. And so as far as what are logical comparisons that we can use, we have the typical ones over here. Just keep in mind, the equal symbol is reserved for like storing something to an object. So this, the logical equal is something different. So when you put double equal sign here, the output of this is something that's either true or false. So if you enter a command that says X, so if you did something like this, what is going to be stored in X would be true. Okay, so what comes out of these operations is either a true or a false. So I think most of the symbols are pretty clear what's going on logically. This means it's only going to return a true if the left side and the right side are equal. And this is going to return a true if the left side and the right side are not equal to each other. So this sequence, this vector that we're creating down here called A, right? Remember this sequence command that we talked about last time is going to start with 2. It's going to end at 16, right? With R, it's inclusive, and we're going to jump by increments of 2. So this would be 2, 4, 6, 8, 10, 12, and 14 is what A would look like. So if you were to print A out, if you were to run this command and then this command, that's what we would see as the output. So if I do like A is bigger than 10, right? This is not actually extracting anything. It's different than saying something like we have over here, right? Where now like because that argument is written inside of those square brackets, that's telling R to extract some subset of A. And here's how I want you to do it, right? And one way that you could do it is say, pull off column 2, pull off column 3, or whatever. Another way that you could do it is pull off all of the elements in A that are less than 6. That's what that would be doing. So just to back up where we're at over here, this is just going to apply this function to each element in A. So it's going to look at the first element 2, and it's going to say, is 2 bigger than 10? No, it is not. So this is going to tell us false. And it's going to look at 4 and do the same thing. I'll just shorthand that with F. And then F, because 10 is not bigger than 10. And then this would be 2, 2, 2. So the output of this command, right, is going to be a vector of logicals. falses and trues depending on whether that number is logically true or false based on that comparison. Any questions? Okay, so I'll assume we're good with our number system here. I don't think we need R to kind of check whether things are equal to 10 or not equal to 10. But I think the subtle thing that you want to be aware of is that this is not extracting anything. It's just applying this logical test to every element in the vector A. And there'll be many times where we want to extract things based on multiple conditions, like pull off every entry in this data set that was taken from Colorado after the year 2005, right? That would be like two different conditions that we might want to indicate. So we combine things with an and conjunction using the ampersand, and or is just the vertical line. And we're not redefining how logic works here. The and operator is going to be true if both of the statements are true. The or operator is going to be true if at least one of them is true, right? Or both of them would be fine too. So yeah, let me open up a poll. That's always fun to do. And because these are true false questions down below. Yeah. So let's before I launch it, let me just kind of, we're going to focus on this command over here, and we're going to use the same definition for A, which was up here. So A is this vector 2, 4, 6, all the way up to there. So if I were to run this command that I just boxed in down here, what would the, well, I don't need a, let's get everybody involved here. So I'll open up the poll here. So what would I get as the first entry? If I were to run this code down below.
False. False.
Yeah, so sorry, there is a poll open. You're welcome to audibly respond. That's fine. This way, it's just nice because I can kind of get a good pulse of what everybody might be thinking. Okay, take another 10 seconds to convince yourself here. Got 13 out of 18 people that are responding. That's good. Right. Last chance. Okay, so here were the results. We had 16 people responded, and we had 2 people say true, and the rest have some level of saying false. And so, yeah, so this is an and. So it's going to take this first, if you weren't kind of sure what we were thinking about, you take the first thing of A, which is 2, and now we're going to apply this test to 2. And it's saying, okay, is A, which is now the first position of A, is the number 2 bigger than 6? And that is not bigger than 6. So since one of those is wrong, right, that would be a false. They would both need to be true in order for us to get true. If I were to run this same command, this second command down here, again on the number 2, right, this would tell me a true for this one, because this part of the test is true, right? 2 is indeed less than or equal to 4. It is not bigger than or equal to 12, but because we have an or operator in there, we just need one of them to be true. So these commands here would create vectors, logical vectors, right, where it's going to do this sort of test on every single one of those values in the vector. Any questions about those operators? Okay, and so down below, we can kind of see the difference between these two commands right here. So if my vector A is 2, 4, 6, 8, 10, 12, 14, and 16, right, this first command over here is going to look at each of these and do that test and say, okay, 2 is less than 6, so that's true. That's true. False, 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 and false. Just to be really clear, right, in R, these are words, true and false. What this operation over here does is it's going to say it is going to extract from vector A based on whether A greater than 6 is true. So for any element, so it's going to kind of do two things at once. First, it's going to do this. It's going to do this logical test, and then it's going to pull off just the elements in A that had a true. So if we run this, it's going to redefine A to just be a logical, no, sorry. It's going to redefine A to just be those first two elements, 2 and 4. And it's going to work similarly for these others. If I put in the logical test A is equal to 10, I'm going to get false, 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 false. There's one true over here. All the rest are false. If I put that inside of square brackets, now this is saying pull off all the elements in A that have A equal to 10. And that would just pull off one element. Running this line of code would just give me the vector A is just going to equal one entry, going to have one entry, which is 10. Okay, so I will kind of stop this material at this point, and we'll kind of jump over into looking at some data frames where some of these ideas will come up in that context. But I'll just say that I will try and do as much as I can using base R as opposed to using any of the other packages, just because it gets complicated, making sure everybody's got the right package and it's up to date and so on. But there will be cases where it's going to be really nice to use some functions that are in tidyverse, for example, or ggplot or things like this. So when that happens, I'll just kind of identify that you will need to install or load some package before that command is going to work. Let's see. I think there are a couple of chats. Sorry. That was problems with the poll. Okay. Sorry. So any last questions about this before moving on into the next portion? Okay, so I am again going to be working with that file, and I'm going to be working in R. So I'll share my R studio. Yeah. Actually, let me do my so I want to look at the rendered file first, since that'll be a little bit easier to display. But keep in mind, this is all typed up in that markdown file. So we're basically looking at kind of chapter 1 of the book by Faraway. So that this LMW, that means linear modeling with our second edition. So that's referring to the text for the book. So if you're kind of curious where we are in the content. We're basically looking at chapter 1. And so this is just giving a overview about, before we even get to the point where we're doing any regression, there's a whole bunch of work that needs to go in. There's like the collecting of the data, there's organizing of the data, there's looking through the data to kind of think about what would be some interesting questions to consider based on this data. And I would say, based on my experience, this is the harder part. And again, I'll just plug 3376 where you get into a lot of these details. And then sometimes, after looking at a couple of plots, that's like your drop the mic moment. There's really not much else to say, like, look at this box plot, look at that box plot. Do you really need me to do a hypothesis test here? I mean, the analysis becomes secondary after some of that analysis. This is not a class in designing experiments or something like that, but I just want to point out that that's a whole broad and interesting field. So we're going to kind of be working with data sets that somebody else has already created. And that leads to some other problems like, when you're working with other people, typically they're an expert in something that you're not, and you're the statistician, and they know a whole bunch about some area. And I'll just say, like, it's not expected that you become an expert in the area that you're applying this analysis to. That's what you have a collaborator for. And so, most of the work comes in talking to this collaborator, trying to understand what they're interested in studying, and then hopefully helping them figure out how to collect data. And then you make sense of the data together. So after you've got the data collected, what I really want to focus on is like, okay, you've got a data set. Now you're ready to do some analysis. What could we do with that data in R? And again, before you do anything, you want to try and look at what's in the data, because ultimately there very well may be some data entry issues and things like that. And I think it's a little bit dangerous sometimes to go into this process already having questions in mind. It's best to go in with the clean slate and just see what the data tells you. But certainly just getting summaries of the numerical variables is really nice. And then thinking about how you can plot things is also really important. So R, or whatever software you're using or programming language you're using, will create all these plots. It won't always know which plot is relevant for which situation. So you'll need to identify, I want to do a histogram here, or I want to do a box plot, or I want to do a QQ plot, or whatever the case might be. So in any sense, this whole portion that I'm kind of just bulleting out here, these are courses in their own right. So let's take a look at how this process might work if we are working with one particular data set. In this PDF, I kind of put some, you can see that things are coded in red where those are things that we might want to talk about together. So I will go into the markdown file since I want to edit that and check some of the output over there. And one thing that you'll see is this large enough for everybody to see my font? Yeah, okay. I added this section over here. If I didn't put that there, what R Markdown does, when you knit this file, it's going to run everything in R, all of them. And right, when I have something like this, that's not the biggest problem, but like it would get down to a point like this where I'm asking you to do something. So R is not going to be able to run this. So everything would crash and you wouldn't get an HTML file out of this. So by putting this statement at the very start, it's just telling R Markdown to not actually run any of the R code blocks that we have in here, just for the sake of generating the text. But now I would like to do some stuff here and actually run the R code. So I'm gonna just delete this, or you can comment it out or whatever you want to do. But keep in mind, that's what this line is doing over here. So if you don't want it to do that, you can just put a comment over here, or you could delete this block because that's the only thing that's in that block. And so again, here's kind of the raw unformatted text in the background behind this markdown file. Okay, so the first thing that you would want to do, if you haven't done this already, we did do this last week, would be to install this Fairway package. If you did this last week, then you don't need to do this ever again this entire semester. Then there are two ways we're going to be working with this data set called PIMA. And there are two ways that you could load that data set in. You could load just this one data set in using this command down below, or you can load the entire library, and this would load all of the data sets into R. So I just loaded all of them. If you want, if you're worried about your memory, then you can just load one of them. And I think one thing that's kind of useful to do and that is, if you're curious, like what are the data sets available in a package? This command over here, data package equals Fairway. And again, now we're not going to knit the entire file because again, we still have blocks of code that are going to crash. We're just going to run like blocks at a time. So to run a block, you just hit that play button that I had, that was over here. And this created some output. It was really large, and it just put it over here. And these are all of the data sets that are in Fairway, and it has a little description of them, in case you're curious. So we're going to be working with this data set today. And you've got another one that you're going to need to use on your first homework assignment. It has you working with another one. Okay, but you don't need to do that. So we're going to work with the PIMA data set. And so if we want to get some information about the PIMA data set, like what is it, what are the variables in it, et cetera, what might be, how could we check that out in R? So feel free to chat it in or unmute yourself.
You could view the structure of it by typing str and then of the data set.
So we could do a structure of PIMA. And this tells us, right, how many observations we have, how many variables we have, what type each of those variables are, and so on. What if I want to know, like, what is triceps, right? So I can see that there's this variable here. So yeah, this tells me exactly like what the structure of the data is. But like, what if you have some other questions that are way more general, like, when is this data set from? Who are the 768 in this data set? Like, what are any of these variables mean? How are they measured?
You do question mark and then the data set you're trying to work with, and
Yeah.
then it in your help menu.
Yeah, exactly. So remember that there's this little question mark command. That's great. So you don't even necessarily need to enter it up here in your code. Usually you just enter these things down in the console. Since you're like, our markdown is like your final report. So you probably don't want to see like all the messy stuff you did in the meantime of like trying to understand what this data is. But if you hit question mark PIMA, you can see it tells us, okay, first of all, here's the library where it comes from. Secondly, this is who did the study, the 768 observations, those are adult female Pima Native Americans that were living near Phoenix. And then it goes into what each of these things mean. So triceps is telling us the thickness of the tricep skin, and that's being measured in millimeters. So if you're ever kind of curious about more of the details of a data set, I will say it's not guaranteed to have nice help documentation like this, but many of them do. Yeah, and so I think, that's a good place to start. Generally, I'm working with the data set. Let me just do question mark data set just to be clear what all of these numbers represent, right? All of these things are representing, in this case, people. That's right. And then these are some good commands to try and get a sense of like, okay, what type of variables are those? And one thing that's interesting is you can see that a lot of these things are stored as integers, whereas they could be things that might, like you could measure the, I don't know how, I've never measured tricep skin, but I imagine like you could measure it to more accuracy than a millimeter. So these things could be decimals, but they were entered in as integers. Pregnant was indicating how many times the person was pregnant. So that should be an integer. That's either you are or you aren't, whereas these other things were being measured. And another kind of issue here is if you look at the test variable, it is 0 or 1, whether or not they showed sign of diabetes. And here it's good to know that this is storing it as an integer. So it's thinking of this as zeros and ones in the integer sense. These are nice commands. Head and tail will display like the first, I think it's 6. Yeah, no, it's written right there. The first 6 rows and the last 6 rows of the data set. If you want to take a look at the full data set, you could do view, and that will display it in a separate thing. So we saw what string does. If you want to just take a look at one of these, could just run like head. Now you can see what the data set looks like. So this will print it to our markdown file. If I do the view command, it will kind of do what happened before. It'll create a new tab where I can view the data set. Okay, so then we want to do some analysis. So when I hit summary, it's going to do a summary for every single variable in our data set. And when it does summary, it picks up on the data type, and based on the data type, does an appropriate analysis. So it's reading all of these things as numerics. We can see that here. Even the test is being read as a numeric over here. So it's taking these numbers and it's going to calculate the mean for the test, right? Which may not make any sense here. So you can see we've got kind of this pregnant category, and then we have all these other numeric measurements for glucose levels, blood pressure, the skin fold in the triceps, and so on. And here's our test character or test variable over here. So looking at this data, does anyone see any kind of red flags in the data or potential issues that we might need to clear up before we do some analysis?
So there are a bunch of zeros. Oh, sorry. I think somebody was raising their hand. My bad.
No, that's okay. Go ahead, Kirsten, and then yeah, we can let Hannah chime in as well.
Okay, so for example, glucose and diastolic blood pressure should never be 0. Same with
Probably not,
triceps,
yeah.
So it looks like some of the values haven't been taken and zeros have been entered instead.
That's right. And so like looking at these minimum and these maximum values are useful because it's good to know when we have outliers, right? Either big or small. And sometimes those outliers are errors. We need to clean them up. Sometimes They're not errors, but we don't want them to influence our analysis nonetheless. And sometimes we want to put a lot of weight on those outliers, and we would want to include them. So it's just good to see this all at once. That's right. And if you're seeing like blood pressure of 0, that's pretty bad. No one would have a blood pressure of 0. So either there was an error in how that was entered, or it just wasn't entered at all, right? Down here, you can see there's a maximum of 17 pregnancies. So this means there was one person in the study who was pregnant 17 times. Certainly that's quite admirable and possible. So, okay, that's a really big outlier there, but I'm not ruling that out as data entry issue. It certainly could be possible. Yeah, were there anything else? I think somebody else had a hand up. Any other issues, potentially?
Age looks kind of interesting, or never mind. I didn't realize it was meme that had the decimal. Otherwise, I thought that would be weird if one of the ages had a decimal, but no others did.
That's right, yes. Or someone was very specific when they were responded to how old you are. That's right. I am 33 years old in 2 months and 2 days, yeah. That's right. So these were probably being recorded as integers, and that's right. The mean wound up coming out to a decimal. And just keep in mind that, you know, oftentimes people like to give like what's called the 5-number summary, the minimum, first quartile median, third quartile maximum. So if you're asked for the 5-number summary, you would just kind of leave out the mean inside here. But the mean is important, and in particular, comparing the mean and the median tells us a lot about the data. It tells us like whether the data is skewed. So if I'm looking at age over here, I can see that the mean is bigger than the median. There must be some large outliers in the data, and we can see that outlier down here, right? Yeah, and then there's a lot of problem, right? No one would have a 0 BMI as well, and so on. So there are certainly some issues. I think another big issue over here is this test, which is saying whether the patient had signs of diabetes or not. You know, it wouldn't really be, what does the mean of that tell me? It's really telling me like what proportion of the population had in this study had diabetes. But it looks weird like this because it's treating it like a numeric here. So we might want to read this in as categorical data. This is really a categorical thing. The 0 and the 1 don't have any real meaning to us other than it's putting it into category 0 versus category 1. Yeah, okay. So I think these zeros are probably the big issue that we have here. So let's kind of clean up the data. And we could do this for any of the variables that we wanted to. They all seem to have this same problem. I think that the pregnant variable seems fine because it's not required that everyone in the study was pregnant at least once. So that certainly makes sense to have 0 here. And age looks good. I don't think there's any issue there. Seems like all of these others, glucose, diastolic, triceps, insulin, BMI, diabetes. Diabetes has stuff here as well. So it seems like glucose, 1, 2, 3, 4, 5 of them had some issues, right, with having lots of zeros. So, right, this code over here, what do you think is going to happen when I run this?
It looks like it'll list the diastolic blood pressure values from the lowest to the highest, or the lowest, I guess, to 40.
That's right. So this sort over here, right, just to kind of see how R is reading this, it first reads this, right? And this is going to sort all of the diastolic values from smallest to highest. And then this is going to say just display the top 40 of them, right? If I exclude that, I'll get everything. So if we run this, we can get a sense of like how many zeros there are. And there's a lot. We could try it with some of the other variables as well to see if it's any worse. So like for BMI, you could do the same thing. And it's different, right? So the kind of the errors in data entry weren't like just the same 30 people, it was different things in different people. So this is kind of just a good way to peek around and look at this. And you could look at the last entries if you were worried about large outliers using similar techniques. So these were either data entry issue, like something was entered wrong, probably that wasn't recorded at all, and whoever was entering the data just entered 0. Or maybe they didn't enter something in the system they were working with by default put in zeros. So in R, right, what's the code that we use for missing values?
NA.
NA, that's right. Capital NA, and it's not a string, so we're not putting that in double quotes. NA is its own thing, means missing value. And it's really important. It's really nice to do things that way because there are tons of options built into different functions that we use in R that are equipped to think of NA as missing data. So we will save some of the trouble for us. So if I want to replace all of these with a missing value, I'm just going to put an NA here, an NA here, an NA here, here, and here. And I think these were the 5 variables that seem to have that issue. And we'll see how that picks things in a second. Okay, but that's how we can do this. And just to kind of come back to what we were just talking about at the start of class with data frames and extracting things based on logical statement, what this is saying is, okay, go into the variable diastolic and perform this logical test, right? And so any value that is equal to 0 is now going to have a true. Anything that doesn't have a 0 is going to have a false. So then this is going to pull off just the entries that had true in it. So it's going to be just the entries that had diastolic that were equal to 0. And this is going to replace all of those zeros with an NA. That's what's happening on each of these lines of code. And you can see here, if you're rendering these markdown files to HTML, that you can enter HTML tags in here to do some additional formatting. So yes, question, Kristen.
What about values that aren't 0? For example, some of the lowest entries in diastolic blood pressure were like 24 and 30, which isn't a valid diastolic blood pressure. So how would we handle those values?
So if you want to set the cutoff to be something else, like what would be a reasonable diastolic cutoff?
Like
I am no expert in this, so. Sorry?
I'd say like 60 could be a valid reading, I guess.
Yeah, then you could do something like this. You know, this would take anything less than or equal to 60 and set that equal to NA. Yeah, but I'll leave it as is. I was getting rid of the zeros, but you could certainly fine tune that. Yep. Okay, so this command over here, factor, right, is going to redefine the test variable, which is at the moment being treated as an integer, 0 or 1. And it's going to instead create, let me just run this code. And then take a look at what happens after we do that. Right, so what this did is it seems like it didn't do anything. It still kept things as zeros and ones. But now you can see that it's saying, okay, we've got two levels, two categories. It's treating this as a category 0 and a category 1 over here, rather than number 1 and number 0. So now it's saying, okay, observation number 1, its value for test is factor 1. Person number 2, their value is, or their category is 0, and so on. So I've already done that, but I guess we'll do it again. And then we can see the output, it's telling us over here that there were 500 people in this study. Test of 0 means that were negative for diabetes, and there were 268 that had a positive test for diabetes. And we could go ahead and replace the 0 and the 1, because probably if you were showing this to somebody who's not as familiar with this data set, that would be their first question, would be like, what does the 0 mean? What does the 1 mean? Usually we want our categories to be descriptive. And so that's what this command is doing over here. So this is, and you want to be careful about the order that you do things in. So it's going to assign negative to the smaller of the first of the levels, which was 0, and it's going to assign positive to 1, which is how we want it. So now that looks a little bit better. Really, it's just renaming the levels there. And there's nothing wrong with how it looked like way back over here. It's just, right, you would need to know that this mean is telling me something about the proportion of people that tested positive for diabetes here. So you'll have to do some cleaning up with the data set on your first homework assignment along these sorts of lines. It won't be perfect. It won't be horrible, but there'll be some things to clean up. Okay, so any questions about that cleaning up process? Was there any other sort of operations that people would want to do to this data? So Kristen had one about kind of scrubbing some of the other blood pressure values that probably didn't make sense or might have had an entry. Maybe they forgot a 1 in front of it or something. Okay, so then comes plotting things, and this is where it's like really nice to do in R. And there are kind of base graphics, and we'll talk a little bit next time about how to use ggplot if you're familiar with that as well. But using the kind of base operations in R, meaning you wouldn't need to install any additional packages. The way that you make a histogram is with hist. And if you're curious about how that works, again, you can always use the question mark hist. And what this usually does is it brings up help document over here, and I'll have all of the different options in here that you can tweak. And so this is what's nice about this, as opposed to, say, like if you're creating graphics in Excel, something like that, right? You actually have to go in and click on a bunch of million things and change colors and so on. Whereas here, you can just type them in. So here we'll get a plot of the diastolic. Oh, that's right. I have an error here because this is the wrong one. Here we go. So here's like kind of a basic plot that R puts together without me really giving it any prompts. And it does a pretty nice job of plotting this. Keep in mind, we've cut off all of the zeros. So this is blood pressure. And maybe there's some errors with these as well. Yeah. So, you know, the typical thing is people like to change colors and things like that. That's fine. So what I'd like to do is, you know, by default, this had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 breaks in the data. So breaks being different bins. So if I want to put 20 breaks into this histogram, what option can I add over here? What do you think the option to add breaks would be called?
Maybe breaks.
Yeah, okay. R is not trying to confuse you. Okay, it's trying to be intuitive. That's right. It really is trying its best to be intuitive. So if you're trying to add breaks, then we're just going to say breaks, and we could add it based on some, you know, algorithm for determining where to put the breaks. We could just specify a number. I want 20 breaks. If I hit play here, I'm going to get an error message. What's the error that I did here?
No comma.
No comma.
That's right. So be just careful about your syntax here, that it doesn't care if I put a bunch of spaces, right? I'm adding a ton of spaces over here. That doesn't matter. It doesn't care if I put line breaks like this either. These are not telling anything significant, but that comma does make a big difference there. So this line break that I added here was just to help the code be more readable. So sometimes people will just put one option on each line to make it easy to see what's going on and make it easy to turn off any of them if you don't want them. And so this is just like grouping all of the values, right? And then counting how many of the observations in our data set had blood pressures between certain levels. And if you want to kind of smooth this out, that would be considered a density plot. Then you need to kind of do two things, which is first kind of create the density distribution. That's what's going on in here. And then plot those values. And so one thing that's interesting, we inserted a bunch of NAs into the PIMA data set. None of these were plotted over here, right? So when you use the histogram plot, it knows to ignore NAs. Not all of the functions in R are going to know to do that. Some of them get really upset when you have NAs and they'll yell at you. And I would say pretty much most of those instances can be fixed by adding this option inside whatever function it is you're working with. And this is why it's really nice to use NAs for your missing data. This tells R exactly what to do. Anytime you see an NA, that just means it removes all of the NAs from the data set before it does the analysis. And so running this code over here gives us this plot down here. Okay, it looks like you drew it with a pencil. That's what happens with empirical data, right? It doesn't perfectly follow a normal distribution, but looks pretty close. And I just added on some additional options that are pretty nice to use. So the type option, all of this stuff is a command, right? Because it comes after this pound symbol. But we could plot it with a line, we can plot points or so on. You can change how it's graphed. I would encourage you to pick your favorite color. You could go ahead and Google our colors. There's tons of them. I'm going to claim sea green. That's mine. Sea green 1, sea green 2, sea green 3. Those are up for grabs. I'm getting sea green. And then this is like the line width, right? 1, 2, 3, 4, how thick you want it to be. But it's really nice to customize your options here. It's not too tricky. Okay, so I will stop here since we've hit our time limit for today. And then we'll talk next time about how we can kind of go beyond these basic plots and do some more interesting plots and use them in our analysis. Okay, but if anybody has any questions, you're welcome to stick around after class today. Otherwise, I've got office hours on Thursday after class. And so we'll be on Zoom again on Thursday. And then it seems like we're coming down from our Omicron peak, and we'll be back on campus next week. So looking forward to seeing you guys on campus next week. All right, well, have a nice afternoon, everyone, and I will see you on Thursday.
Thank you.